Perfect. Well, then, because Stefan already introduced me, I don't think that I'll need to do that again. So also welcome from my side, and let's actually dive into the topic with OPC UA over MQTT. But before we really get started with some technical details, and don't worry, I'm not going to show you like how the messages are encoded on the wire and things like that. There will be some screenshots and excerpts from such messages, but I will not talk about that in detail. So it will not be too technical. It will really be a good generic overview over the features and everything that we have. But before we do that, I just want to get started with creating a common baseline and just talk about why our IoT and especially industrial IoT approaches and problems or sometimes problematic, right? What are the typical things? And I'm very sure, as we have only end users on this call right now, that you have experienced that as well, right? You have run your IIoT projects, and they are usually always running this, running are realized the same way. Most of them are identifying MQTT for their cloud connectivity. They create initial architectures. They create their own first MQTT mappings, because that is something which is just quick and provides you a very quick success, right? You define your own payload, you send it from a device or from your own code to a broker, then to the cloud system. You see the message, you can interpret it there. Perfect, right? So you're happy. Quick success, that is exactly what everybody wants. Then you go into a little more details with your development and the integration, and that is when you're starting using the MQTT realizations in the actual products, right? And in those cases, what you often find are either some predefined standards or pre-implemented standards that you can leverage, like OPC UA over MQTT, but also in most cases, a very generic MQTT interface that just allows you to define your own payload with some placeholders where then the data will be inserted. And with this, you verify everything that you have in a first pilot project, and everything looks great. And then you try to roll it out global. And that is where suddenly you are facing new issues that you potentially haven't thought of, because the same machine type may be provided in one region by one vendor, but in another region by other vendors with different hardware, with different feature sets. So you're now facing not only new machine types, but also brownfield devices, brownfield machines that don't even have MQTT support. Now you need gateways and everything. So you have a bigger diversity of the suppliers. And in some cases, when you put too much information in, for example, the payloads or into retained messages, you're actually running into architecture limitations. And this is just what's happening normally, right? So looking at a very typical IIoT project, how the communication is being set up. You have your devices which are either already supporting MQTT as I described, or they don't support MQTT yet. Then you put a gateway in front of them. You define your own payload, put in some structure, some information. You send all of that off to the broker. You bring it to the cloud where you get your own JSON pipeline that your IT people are writing, right? And they are now destructing the message that they know. And asking the OT experts, what is this data really meaning, right? So that is where the OT people are needed to come into the game, because if you have just the data being transmitted, then you need to have you need an understanding that all the information modeling pieces that Stefan mentioned before in the introduction. That is stuff that you need to really interpret it. You cannot do data science. You cannot do predictive maintenance or all those AI mechanisms to do investigations and find issues if you don't understand the data that you have below your hands. So you need those OT experts. And the problem here is, just like always, that is something which comes in addition to their usual task. So that makes it just difficult, right? Because they already have limited time beforehand. But this is how this often looks like. And we already talked about one thing, and that is one of the key problems that I'm seeing in those IoT projects. That is, whenever you transform data or metadata, you very often lose information. So assuming that you're starting with a machine, with something, or with a flow meter, which already has an OPC UA interface, then what you're getting is actually not just a value. You get status codes and quality information about the data. You get timestamps, not just one. You actually get 2 timestamps. You get a relationship of the data. So where is it? What is it related to? You get semantical, this is basically the semantical meaning. You get the engineering units. You get so many information. But when you transform it to something that is initially just considering getting the data from the OT to the IT, you very often lose all of that information. And then you transform it again to actually store it in, for example, a time series database, which doesn't have any knowledge about relation of the data anymore. And this is then where you have real problems, because now what you created is just a big data lake, and it requires the data scientists a lot of efforts and a lot of talks to OT people to actually recreate all those relationships, all those semantical meanings, which were already there the first hand. And this gets us to the big benefits with OPC UA systems. And that is actually happening in different architectures, right? One of the big benefits when you stay within one technology is that you can get applications communicate directly with each other, even though they initially weren't considered to do that. So you can create just not only like the traditional automation pyramid that most probably everybody on the call knows anyhow, but with OPC UA, you already have been able to basically bypass layers, right? You can now suddenly connect the cloud system directly to sensors and pull the data out, or you can publish the data, even though initially that was not the intent of the sensor for a communication path. So with OPC UA and having all these flexible things, you can create traditional ISO 95 hierarchy, like the automation pyramid that we know, full information meshes where just everybody communicates with everyone on a point-by-point basis. So you have very distinct communication paths, or you can create what's very modern today and quite a lot in a hype right now, so-called unified namespace. The beauty for OPC UA is it really doesn't matter. Everything is possible with OPC UA, and that allows you to, even later on, if you really want to, you can even change it easily, because you don't need to change the technology. You just need to change the communication paths. And this is a configuration change, no implementation difference, and that really makes things way easier. So those are the big benefits of having like OPC UA system architectures. No project-specific development, but configuration. You're not losing the data or the metadata, because OPC UA provides you a mechanism to get these semantical meanings from your OT world to the IT world. So you already have them when you look at the data. When the data scientists do an analysis, they find the relationships without the need of pulling in OT experts. Of course, they can always provide more data or more information, but at least you have a very good starting point for some generic interpretation. With having or being in such systems, as you may know, OPC UA is really not just a protocol. So OPC UA is not only defining a message to get the data from A to B, it looks into the system as a holistic approach. And that really allows you to do application device registration and onboarding. So we have specifications for that. We take care of certificate management, of security configuration, and doing that with supporting all those different architectures. So this is just the baseline, right? And that explains to you why this, when you have OPC UA interfaces already in your OT world, why leveraging OPC UA over MQTT to get your data from the OT to the IT is a very natural next step, a very important use case. So with having that said, let's actually dive into different use cases and concepts. So what is defined with OPC UA over MQTT? What does it really talk about? What are we looking at? As Stefan already indicated, MQTT has been chosen by many IoT projects. The PubSub spec for defining the MQTT mapping and the encodings are actually released already quite a while. So you will find already products on the market. So this is nothing which is brand new. Of course, there's always an adoption curve, but still, this is nothing which is brand new where you don't find anything. You can just buy products off the shelf. Also, Gateway supporting that. OPC UA over MQTT is not only supporting data messages to be sent via MQTT, but also events. Just like in client server, you have the same mechanisms here. You can use OPC UA over MQTT with 2 different MQTT versions. So there's a definition for version 3.1.1, and there's a definition for version 5.0. The big difference, and I'm not going to go into any further details, but the big difference is whether some encoding information and information about the payload are either in the MQTT header or not. That is the big difference. But with having all of that and having the semantical meaning, having these information model defined, especially with collaborations of other organizations, when they are looking at OPC UA systems, what they tell all their members, their vendors that they work with, that they should really choose OPC UA over MQTT, because that allows you to maintain all this knowledge and get that to the cloud. And that is why the Open Industry Alliance is working with that. Umari is working with that. Spectaris is working with that. And several others around the globe as well. I just didn't want to create a too long list to overflow the actual slide, right? But you see that there's a lot of push behind it, and especially the consortia are seeing big benefits in doing that. Now, I said I won't go into too many technical details, but we need to talk about at least some generic technical details, and that is with OPC UA over MQTT, because the payload is really not defined, so nothing in there is defined, not even the encoding. You can have different encodings, and you can also do that with OPC UA. In that case, what we have is we have a JSON encoding and we have a UADP encoding. And JSON is the one that most of the IT folks are usually working with, and because that is what they are used to live with, that is what they're getting from the devices in a generic thing. The beautiful thing here is that you don't need to have like generic encoders that are aware of OPC UA to really interpret the data, right? You can just, JSON is text, you can just pull the JSON and you can start the processing and the analysis of the data. That allows you to also integrate products which beforehand or which currently don't understand OPC UA at all, right? So if you would happen to be on a cloud system of a vendor which is not part of the cloud initiative and doesn't have a OPC UA over MQTT integration yet, you can just use their normal JSON pipelines and destruct the message, and you're just in the same world as you have been before. And for the optimization or for the efficiency of the communication, there's also the mechanism to actually zip and compress the messages, and that just saves some bandwidth. The other option is UADP. UADP is a binary encoding, and that big difference, and that is why I pointed out very clearly, UADP needs to that both sides in the communication understand, or all sides in the communication understand OPC UA. Because now you are in a binary encoded world, and without knowing which bits actually mean what, you cannot really interpret the data. But it brings advantages, and those are not just tiny ones. It is way more efficient. So in this very simple case here, the size reduction was already around 75%, because you have pre-built knowledge in that case, and you're not transmitting text. And also, it allows you to utilize OPC UA PubSub security, and that is something that I talk about a little later. But this basically means you can send encrypted messages with so encrypted MQTT messages through the whole chain of brokers without anybody being able to read it, except for the ones which have the rights to actually read that. Because we now talked about efficiency and scalability, I just want to point out the definitions that I'm using, because I know that some people use different definitions out there, especially when you look in social media and have a discussion on the actual bandwidth optimization of every message. Scalable solutions to me is what end users really are looking for. That means that without additional coding effort, without big overheads, without special coding for everything or special pipelines for everything, that you can reuse concepts, reuse ideas easily. And that makes it a scalable solution, because now when you bring in new devices, the existing system will still work. You will have some configuration changes, and then you're just getting ready and you get done, right? So scalability for me means that it's easy to realize, easy to change, easy to configure. Then you can have big deployments without a big worry. On the other hand, when you look at bandwidth optimization, to me, that is efficiency. This is really how much bandwidth do I need? What is the memory consumption? What is the computing power that I need to process all the messages? And now the problem is, unfortunately, whenever you create scalability by putting in meta information or information that allows applications to understand the data, to interpret the data, whenever you put that into a message, you reduce the efficiency. So there's always a trade-off, and that is something that you need to keep in mind. As I already pointed out, you can use OPC UA over MQTT with JSON encoding, with OPC UA-aware applications and non-OPC UA-aware applications. And we have different JSON definitions for that. Like I said, I don't want to go into all this detail, but there's the important thing that you need to take away is there's one JSON encoding available, which is self-describing, which provides you additional information about the data in a textual form that allows you to interpret everything without having specific knowledge about OPC UA. So that allows the OT people to send standardized OPC UA over MQTT messages. And if the IT is just not ready yet to consume them, they can still use their JSON pipelines to destruct the messages, and they will understand, though, what they're getting. So we have talked about different messages or different encodings right now. So let's look at different kind of messages that we use for some standard use cases or for different OPC UA over MQTT use cases. When you look at the specification for OPC UA over MQTT, what you'll find are message types which are describing how data is being transmitted or events, how to realize discovery, that means how you can identify new publishers coming to the network, and a new concept or a concept which is called actions that I will talk a little later on, but this allows you basically a feedback from the IT to the OT to change and write things in the OT world. The important thing here is that not all of them are things that you want to send cyclically or periodically. Because again, what you want is you want to optimize the communication to the cloud. You don't want to send high frequent messages which are not changing. So what MQTT allows here is to utilize retained messages, and this is also what we are using in the OPC UA specification. So that means that for the discovery use cases, you send your message to the broker once, you mark it as a retained message, and then whenever an application comes along which wants to consume the data, they will immediately receive the identification messages, the discovery messages, and that allows them to understand what's going on. Of course, everything which is really changing is cyclic messages, and they will just be sent frequently so that you have the latest process values. With everything that we defined here, and that is something which is very important because it's a very special thing when looking at different trying to standardize the MQTT payloads. What OPC UA has chosen to do is to keep the data topic tree flexible. And this really allows you or brings you abilities that you don't have with a lot of the other technologies, because they put many details in the actual topic tree, right? So they, because they don't have other ways to standardize information or semantics, for example, they use the topic tree for doing that. And because of that, you're basically bound to whatever they define. The problem is that not all the plans out there are really following their definitions, right? Not all of them are ISO 95 all through. And so one of the early feedbacks that we have received from the in the OPC Foundation from end users when we defined all of that in 2018-ish was that the data topic trees need to be flexible. And that is what we did. So you can really define the data topics as you like. And your plant hierarchy is a different one, use a different one, right? So that really allows you to be really flexible. It allows you to scale things because now you're not meeting like limitations in details in the topic tree. Many brokers have limitations when it comes to the length of a topic tree. And when you want to go too detailed with the devices and the sensors, then your topic tree gets so long that you actually cannot send it anymore. So you need to create aliases and so on. So it just becomes more complex. But while we do that, what we still maintain, of course, is the interoperability. Because, like I said, for us, the data models and everything, they are not hidden in the topic tree. So that allows us to be that flexible. Of course, for some use cases, we still define standard topic trees. You could still change them, but they are standard default topic trees defined. And that is for for example, for the discovery. That means that while the data is flexible, data messages, discovery messages are sent to a very distinct topic tree. In that case, it's the UA metadata that allows you to discover how the data that you're receiving. And this is really describing like the data in the data messages so that you get the engineering units, the data types, the different fields which are included, whether you have scalars, whether you have arrays, and that just allows the receiving side to prepare for the messages that they're receiving, and that allows them to easily interpret the data. It also manages a configuration version. So if on the sender side, on the publisher side, you would change the configuration and you will send different set of data, then actually the subscribers will notice. So that is already built in. Another use case, automatic publish discovery. Same thing here. Of course, in that case, the topic tree is standardized. So it is defined. It is the UA status, UA application topic that you're publishing to. And what this really provides you is a standardized mechanism to discover publishers that are sending data to you and do some very general condition monitoring. And that is what has been implemented here in a cloud dashboard together with Microsoft as a demo, as a proof of concept, where basically the messages, the standardized messages are just consumed and identified, in that case, the publisher as operational. And the big beauty here is because OPC UA is domain agnostic, those dashboards are actually working with any kind of devices, right? Because it is the discovery message and the status message are very generic, and that allows you to just push them. And no matter whether you're in the oil and gas industry, in the energy sector, in packaging, in building automation, in working with robotics or in discrete manufacturing, it will always look the same. So you can create standardized dashboards. And this makes it very interesting for IT companies because they just have the implementation effort once and then can roll that out in all the different domains and verticals. In certain cases, you also want to have a connection back to the actual OPC UA server where the data is coming from. And this is also a use case that potentially you don't need, or you think that you don't need that today. But just having the opportunity that a publisher is sending a message that identifies its endpoint that you can connect to with an OPC UA client to get full access to the server is something which is very handy, because with that you can look at the information model. You know where the data is coming from. If you get any issues, You can tell the maintenance engineer directly where he needs to go to and how to connect to this OPC UA server without the need of looking in additional project-specific documentation in somewhere in a folder in the basement where you find, okay, and that publisher ID was the machine XYZ in the corner of the plant, right? So it really helps with some standard use cases here and finding this OPC UA server, and allows cloud services to get and gain additional data if they need it for some of their use cases like data analysis or predictive maintenance or whatever they want to do. The next thing are the PubSub actions that I already mentioned. This is a concept where now we basically turn around the communication where the IT system, where the former subscriber becomes a publisher themselves, and now they can send a request via OPC UA over MQTT. So you're still in your MQTT scenario, is now sending a message to the devices, to the machines. And this allows you to do very generic things like you can trigger actions or activities in the OT world. You can write new set points. So assuming in the future you did some great analysis with AI and you notice that the humidity is going to be bad in the next few hours, and therefore you need to write a new set point to something, then you can just do that by using the PubSub actions, and you staying in the MQTT communication flow. So no additional firewalls that need to be opened, no additional exceptions that you need to request from your IT world. You just have a standardized path to go back. And of course, that also leverages then the security that we have in OPC UA. So that is something quite interesting. Speaking about security, as you know, OPC UA has security built in. So that is something that was always there by design. And I'm sure you know the slide, so I'm not going to talk about that. It's just a reminder that we do have a security working group that are really working with national security agencies to keep OPC UA as secure as possible, and to also realize, new requirements like you get by the CRA for the vendors or by NIST for the actual end users, right? And they were involved with the whole PubSub security as well. And that is why we have a big benefit when looking into OPC UA over MQTT. Looking at MQTT security, the security that is being provided is TLS channel between actually the broker and the application. That means between the broker and the subscriber, there's a TLS channel, and there's a TLS channel between the broker and the IoT agent in my example here. The problem with that is that everywhere in between, the data is always there in clear text. And that really means that if you have like a broker cluster where you have multiple brokers which are sharing information and sending messages across each other, every single broker will have full knowledge of all the data that is being sent. So they have full access to the payloads. In many cases, this is not a problem because you can secure the brokers, or the brokers are secured by the IT companies. But there are scenarios where you actually don't want to have that, where the data being transmitted is so confidential and so important to you that you only want to have the applications actually using it being able to access the information. And this is happening with OPC UA over MQTT and binary encoding. What you're now getting is you are in the PubSub security, and this security allows you to sign messages so that they cannot be modified by any of the brokers in between. But also you can encrypt the messages, and that means that none of the brokers, even though they have access to the payload, they would just see garbage. And that means that only the actual subscriber that is expected to receive the message and interpret the message and has the security keys to decrypt it will see what's in there. And even better than that is that the whole PubSub security is not only providing you that mechanism to really do this encryption part or the signing part, but it also looks into how this needs to be configured, how the security is managed. How can I get the keys from my to my OT devices and to my IT services to actually interpret the data? And all of that is part of the OPC UA ecosystem and the security management. So this really allows you to come up with complex scenarios, use already on the market available products and solutions, for example, for the key management, and utilize this for making sure that your data is as secure as possible. So leaving the use cases and the technology, going into the different integration options and just describing on what is kind of obvious, but just to spell it out. When you're integrating OPC UA over MQTT, you always have two options in an overall solution. You can natively integrate it. This really means that you're using OPC UA and you're bringing it natively into your OPC UA server or OPC UA client. So the MQTT part is just an additional piece to something which is just existing there. And with that, you have a native integration, which is always faster because there's no additional hop. It's easier to manage because you just have one application that you need to manage. And you have better control over the publishing of the information and everything because it's not decoupled from the actual data generation. But of course, there's also another option, which is you can utilize gateways. So whenever you have an OPC UA server in a brownfield scenario or where just OPC UA over MQTT is not implemented yet, you can just put a gateway in front of it, and which is an OPC UA client, pulls out the data from the OPC UA server, translates it to MQTT, and sends it to a MQTT broker. That is a standard use case, and you will actually find several open source solutions out there if you want to play with them, but also commercial products that you can just purchase off the shelf, which are doing exactly that for you. And you will find those actually listed on the OPC Foundation website. So going back to the architecture slide, what does all of that mean? That means that with OPC UA over MQTT, we have created a standardized mechanism to have this interconnectivity, especially between the OT and the IT, but also between IT applications. It always depends on where you start with, is the edge inside IT or is the edge inside OT? But you can use that for getting data into data spaces. You can use that to get data to your cloud suppliers. You can use it to get your data to other IT applications, right? So whenever you want to utilize a PubSub mechanism in the IT world and MQTT is the thing that you want to do, you can use OPC UA over MQTT and still be in this great ecosystem that provides you security, discovery, data transmission, information models, natural understanding of the semantics, meta information like the engineering units, and so on. And as we already said, this is nothing new, but that is something that is already available for a while. So what have we done in the meantime? Well, at the OPC Foundation booth, and this is also the invitation to join us at Hannover Messe, for example, or at SPS, because we usually have this demo with us, and there we can go into more details. But we have created demonstrators where different vendors with their devices are either natively or by using their own IoT agents and boxes as with basically in a gateway solution, publish data to a central broker. In that case, we are utilizing HiveMQ, and that is then the connection for different dashboards. The two cloud vendors that provide the dashboards are actually Microsoft Azure and AWS. And you see that there's a big list of OT companies that are doing that and in different industries, actually. Now, as I said, different industries. So we did exactly the same also in during ACHEMA already a while ago for the process industry, where the company Samsung has actually onboarded their flow meter here in this demonstrator. with an open source gateway to the dashboard within a few hours. So I think it was just like 1 or 2 hours, and that included getting to know what needs to be done, cloning the repository, configuring, and bringing the data to the dashboard. So you see that being in this OPC UA world really speeds up the process. And where are we with this demo today? Today we have over 35 companies that are actually participating. We are not only having Microsoft Azure and AWS providing dashboards. There's actually also a company called Inchstone, which is providing a dashboard for handhelds. That is where they're coming from, and they also have integrated OPC UA over MQTT to do that. We have onboarded 18 companies with their products from the laboratory and analytical device industry within just 2 weeks. So you see that this is something which is, even if you have very diverse products and companies and environments that you have, you get this actually done very quickly. And what you see on the bottom picture is a picture from the company Chevron at their SPS show booth, where they presented an IO link master with an OPC UA over MQTT interface that gets basically the data from the IO link master or from the IO link devices through the master into the IT system with OPC UA over MQTT. And for them, it was that critical important that this demo that they created themselves was actually in the center of their booth. So there was very prominently displayed. So you see that there is adoption behind it and there is a drive behind it. If you now want to play with it yourself, if you haven't seen that already, if you're not using OPC UA over MQTT yet, well, we do have an IIoT starter kit. That is not only for academic, but also for all engineers that are just interested in it. You'll find included standard publishers, subscriber, a quick starter which guides you through the process on how to create the different messages, how discovery is working. There's also examples included how to create a UNS, for example. So all of that is open source available. The link is on the slide, so feel free to just connect with us and look at it. And that gets me to my summary for the different use cases. As I outlined, and I hope that that was a good run through everything that we have. OPC UA over MQTT provides you a lot of different mechanisms that potentially you may not need at the moment when you start your IoT projects, but over the time you need them. And when you are now already realizing your projects with using that standard technology, then whenever there are new standards or new products coming out using this standard, they are easier to integrate. You can leverage other use cases which are already available by just simple configuration changes. And this doing all of that with having security in mind, selecting the payloads or the encoding as you require them, as you need them. And with that, what you get is a future-proof solution that allows you to support different system architectures that you can change by reconfiguration if you need to. Security mechanisms, which also considering the configuration and the management pieces, so that makes you future-proof there. And that actually also allows you to bypass layers whenever you need. And with this, at the end, I hope it was a comprehensive overview. And well, if you have any questions, please feel free.
Thank you.
And thank you also from me for the presentation, Alex. Well done.
Absolutely. Thank you so much, Alex. And I asked the attendees to put questions in the chat. This has not happened till now, but I received, interestingly, some questions by email. So it looks like nobody wants
that's good.
Yeah. So I try to categorize them a little bit. It's partially addressing security. Some are how to implement with some implementation questions, and some are also on features. So let's start with some questions on, you mentioned 2 different versions of MQTT, version 3.1 and version 3.5. And I have 2-3 questions on the top roundabout actions. MQTT actions. So does MQTT version 3.11 also support actions?
No, it doesn't. I think for the actions, you actually need MQTT 5.
Okay, and then let's stay with actions, because this is where most people also, I got two more questions here. You explained it that an action is just the vis-a-vis connection that so the OT is pushing telemetry data to the IT via MQTT, but then if the IT wants to reply on something or do a set point of something, then you call this action. So isn't this just that now the IT is the publisher, and thus the OT world has to implement a subscriber?
Well, in that case, yes, they will need to, because they need to receive the messages that are being published by the IT. But what you will find is that in most of the products that I'm seeing, usually both sides are implemented. So when you look at products also in the OT world, like the different PLCs, they are not only implementing a publisher to push the data, they usually also implement a subscriber to receive data. And so
okay, but if the interaction is you implement both publisher and subscriber to send something out and be able to receive something, what is then the specific meaning of action?
It is a standardized mechanism. So what you...
It's the payload. It's the payload. Yeah. So we define the payload for the actions.
Okay.
So and I mean, to back up Alex's point, I mean, it's trivial to also implement a subscriber. I mean, all MQTT libraries support both, right? I mean, it's one command, okay. 5 lines of text, 5 lines of code to implement a subscriber.
So right? So let's take a generic example here. If you think about an OPC UA server that you have, which has included a method to call to, for example, change the position of a valve or of a choke. What you can do with the action is basically the same thing that you can do with calling the method to change the choke.
Yeah, okay.
So it's not just a generic receiving data. It's actually with having the meaning of the information model, it already knows what to do.
Okay, it's a method call then. Okay, got it.
Yeah, I think Randy also wants to.
Yeah, I just wanted to make it clear that actions are not dependent on the broker. So you can use actions with MQTT 3.1. You can use them with 0.5. You could use them with Kafka. It's one of the things with the way PubSub works is we tried to be as independent of the actual transport, but what we did is we added features to take advantage of MQTT when it's available, but we don't necessarily require for the core features. And the other aspect of sort of the two-way communication is important to remember. As soon as you're talking about writing back to the PLC, you have a security issue, and it's very important that if you're going to allow that you have a good strategy for ensuring that only authorized users can actually write back to the PLC, because it's potentially disastrous. There's some complex system engineering that needs to go in if you're even considering that,
okay, great.
So by default you would want to be looking at read only.
Yeah. So it's great to have both experts here today on the call. Also, Erich Barnsch at Microsoft, who is the leader of the chairperson of the Cloud Initiative. I introduced him before, but also Randy Armstrong, who is not only our security chairperson, but also doing a lot of prototyping, and he's part of the core team. Other questions here?
Before you move on, Stefan, so if you want to try out actions, the IoT starter kit has them implemented. That is available open source on GitHub, and the Cloud Commander and the Cloud Action, which is also available open source on the OPC Foundation GitHub, were specifically built for that use case, but we yet have to update them to the new action spec. That's not done yet, but they already implement that use case that I think Cloud Action queries data from a database and then based on a threshold value executes a command via Kafka or MQTT. You can pick your protocol, and then the cloud commander sits on the edge behind the firewall, subscribes to the broker topic to receive the action and executes that action then as a client-server method call or a read or a write or whatever you want on an OPC UA connected server.
Okay, good additional information. So then I have, so that has been the 2-3 questions on actions. Now I have 2 questions here on the more the implementation. And because Alex did the presentation, I'm addressing him here. Alex, well, I'm asking all the questions. So how difficult is it to implement this MQTT? Do I need an SDK, or do I need a full, complete OPC UA server at all? Can I not just publish out of my chipset directly OPC UA over MQTT JSON compatible format? So, and if I do it without a complete OPC UA server, is there any disadvantages? So roundabout implementation, all of that.
Yeah, so that is really what, in that case, I absolutely suggest looking into the IIoT starter kit. In fact, it is not required to have a full-blown OPC UA server in an application to use OPC UA over MQTT as a publisher. You can construct the messages just as messages and then send them out. And that is exactly what you'll find in this starter kit. Under the code name Quick Starter. So the Quick Starter will really guide you through the process of having nothing, then starting with very simple use cases in an OPC UA conformant way to send data to another point, then adding the discovery of the data, then adding the discovery of the publishers. So it is not needed to have a full OPC UA server to publish OPC UA over MQTT data, and it's also not required on the other side to have a OPC UA client to actually understand it, right? Just subscribing it and destructing the JSON message, as I described initially with a JSON pipeline, is absolutely possible, so that is easy. Nevertheless, if you want to integrate OPC UA over MQTT just natively into your product, you get like quite some benefits. And there's actually one company that I just want to highlight real quick, because what they did is they brought the whole PubSub communication into the cycles of their PLC. And that is, in that case, Backoff. And that is the only one that I'm aware of where it really is that deeply integrated. And what they have been done is you can really, within a cycle of the CP of the PLC, you can basically say, send out this message with OPC UA over MQTT. This is nothing specific to the MQTT part. You can actually also do that with the PubSub UDP communication. So they're reusing what has been there for use case and just implemented that very generically. And also, that just gives you way more options and way more flexibility, because now you're faster, you don't have additional hops, you're not transforming the data, it just comes directly out of the data producer.
Yeah, but I think I'm also allowed to have a question, my personal question. Education for the president. Okay.
Yeah, we can definitely explain something about OPC UA to you, Stefan.
Thank you so much. I'm not shy to ask stupid questions, maybe. Oh, okay, I got the message that if I have a chipset, 8-bit chipset, and I can send out an MQTT message in an OPC UA compatible way and have my JSON message out. Okay, I understood this. And so the other side, the dashboards from AWS or from Microsoft Azure do not really see has this message been sent out by a full-blown up OPC UA server or from whatever device. Okay. But Alex, you mentioned also the benefits of if everything needs to be highly secure and confidential and nobody can see the JSON inside the broker, and then you recommended to use the binary format and then encrypt the binary format, and you mentioned that it's signature, it's included, nobody can change it. So if you add signature and certificates and then whatever, this is all comes out of the package with the UA server, right? And otherwise you have to implement that.
Correct.
On your own. Is that correct understanding?
Absolutely correct. Also for the distribution of the security keys. So the way that we do security, like I said, we luckily OPC UA is not only providing you the encryption part for the messages, but really taking care of the security management and configuration as well as with a system architecture, right? As a system view. And that means that, of course, we have a mechanism to get the security keys to the publishers and to the subscribers. And guess what? That is OPC UA as well.
Right. Okay. Got it. Because I had a talk with one of the customers in a specific domain. They said everything is highly confidential. We need to sign and encrypt everything. Okay. Got it.
So hold on a second, Stefan. So usually you have your own security layer with MQTT and Kafka and other PubSub protocols like TLS. They usually use TLS, right, as a security layer. So you don't necessarily need to implement anything yourself. And when you're using, a broker, all modern brokers support TLS, right? So that's how you would do the signing and encryption if you do it to TLS. So
yeah, but I listened to Alex's presentation, and he mentioned if you're using JSON, then you are not sure, you cannot be sure that somebody inside the broker is listening to your message.
So the encryption and the payload are two different things, right?
Okay.
So you can also, if you're sending a binary payload, you can also listen in on a non-encrypted channel.
Sure.
Right. So you need to keep those things separate. Also regarding the dashboard, these are not Azure or AWS dashboards. This dashboard that the OPC Foundation uses is actually platform independent and available open source on the OPC Foundation GitHub, just like the other stuff I mentioned. So it's actually platform independent. Anybody can use it.
Okay.
And it's MIT licensed, so it's meant as a starting point for building your own dashboard. On the other hand, of course, most cloud providers have their own dashboard built into their services. So you don't need to do it, but you can if you want to, and it's available open source.
Got it. Okay. One last question in case nothing additionally is coming in here. That's more, features or application layer. So somebody is saying when he's using OPC UA client server architecture, with TCP in between, and I know his way is coming from water treatment and so on. He says there's a mechanism built in for automatically data buffering in case the transportation line gets interrupted, so that the client is wishing for some items. If my 2, 3, 4G whatever line is breaking down, the server is realizing I can't send out, I'm disconnected from the client, I can't send out my value changes, and so the server starts buffering the data. And once the transport TCP/IP channel is re-established again, then the client realizes, I missed 40 callbacks, messages, because each message has a unique message number. Oh, great. So this is a fantastic UA feature that a disconnect doesn't automatically mean you lose information. Is something like this also available in transporting data via PubSub over MQTT?
Yes, it is. That feature is called Store and Forward. Most PubSub clients have it. For example, the open source UA cloud publisher that you referred to at the beginning, Stefan, has that feature. And it's very common to implement it that way. Of course, there's also quality of service available inside protocols like MQTT and Kafka, which send acknowledgements and so on. So even if you are on a lossy connection, you can be sure that all the data eventually makes it to the destination, in this case, the broker. And then similarly, when you're picking up the messages from the broker through subscription, you can also basically specify what should happen to the message in the broker. Should it be kept or deleted.
Okay.
So that's all available, and of course it works quite well. So I use the cloud publisher in my own house for my smart home, and when I have a power outage or internet connectivity loss, and the power comes back, and so I have a backup power. So when the power comes back and the internet connection is reestablished, I can see how the data eventually trickles into the cloud. So it works quite well.
Cool. Okay, with this, there's no other question I'm asking here to the audience. Is there something else? Then be vocal right now. Otherwise, I just like to say, I like to remind the audience that if you go to the OPC Foundation webpage, opcfoundation.org, and then /cloud, you find a comprehensive overview on all activities and offerings and brochures and so on. We are constantly optimizing this page, but it's definitely a good starting point. I'd like to thank again Alexander Allmendinger for his presentation today. Thank you, Alex, but also thanks to Renny and Erich helping here on the Q&A. With this, have a good day, good evening, good afternoon, good morning, wherever you are in the world. Thank you so much. Bye-bye.
Bye-bye.